everyone, in this lesson we'll be dividing polynomials. We're going to start with dividing a monomial by a monomial. So let's look at some examples. In this first example we have 3x divided by 9x. So take it a piece at a time. Look at the coefficients first. So we have 3 over 9, so that could reduce to 1 over 3. And then x over x, we can essentially cancel those out. They have the same power. We're really dividing x by x here and dividing x by x here, which would make a group of 1 to make a group of 1. And if we multiply by 1, we get what we originally had. So the whole thing just simplifies to 1/3. All right, let's look at a little bit more advanced example. All right, again, we're going to start with the coefficients. All right, 15 doesn't go in evenly to 24, but they do have a common factor. The biggest number that goes into 15 and into 24 is 3. So 3 goes into 24 8 times, and 3 goes into 15 5 times. Great. Now for the variables. Since we have x to the 8th and x to the 3rd, that's really 8x's multiplied by each other over 3x's multiplied by each other. So we can basically cancel 3 of these out, leaving us with 5, and we cancel all of those out. So there's no more x's left on the bottom, but there is an x to the 5th left on top, and that is our simplified expression. Let's look at another one. This time we have 18 over 14 as our coefficients, and when we simplify that, we look and we see 2 is the biggest number that goes into both, so we have 9 over 7. Now when we look at the variables, we think back to our rules of exponents, we have 2 on top and 7 on the bottom, so that really just leaves us with 5 on the bottom. There was more on the bottom to begin with. We cancel 2 up here, we cancel 2 here, and that leaves us with 5. So that's dividing a monomial by a monomial. But now let's move on to dividing a binomial by a monomial. So remember, a binomial means 2 terms. So we have 2 terms in the numerator over 1 term in the denominator. Now it is important that both terms in the numerator, we have to pull out the same thing from both with respect to the denominator. So I have to look at 35 and 15, but also 20 and 15. So really I'm looking for something that's divisible, that goes into all 3 terms. We have like a term here, 1, 2, 3 terms. So between the 3 coefficients here, 5 goes into all 3. And there's no x's on the bottom here, so we're not going to change the x's at all. So if we divide 35 by 5, we get 7, still x squared. Divide 20 by 5, we get 4x, and that's all over 3. So we found a factor of 5 that went into all 3 of those terms. All right, in the next example, we can look at all 3 coefficients, 5, 35, and 20 again. And if we divide all 3 of those by the greatest common factor, which is 5, we get 7, 4, and just 1 on the bottom. Now let's look at the x's. We do have 1x here, and 2 x's there. So if we divide by x, this will cancel and that will cancel, but we still have 1x left here. So we'll have 7x plus 4, and the whole denominator has been canceled, so we just have a 1 there. If you just have a 1 in the denominator, we can simplify that to 7x plus 4. Let's look at another example. So here again, we'll go through the coefficients, 24, 10, and 28. All of those can be divided by 2, so we have 12, 14, and 5. Then we'll go ahead and divide the variables by the most that they can all give. They can all give at least 2 x's, so those will be totally gone. We'll be left with just an x there, and if we take away 2, we'll be left with x to the 3rd. So we have 12x to the 3rd plus 14x all over 5. And so this time we still have something left in the denominator, so we'll just leave it as that. So that is dividing a binomial by a monomial. Finally, we're going to look at dividing a trinomial by a monomial. So, like the last one, we had to look for each term in numerator and denominator to have the same GCF, same common factor. Now we have a 4th term. So 1, 2, 3, 4. All of them need to be divisible by the same term. Well, they can both be divided by 5. So we have 6x squared plus 3x plus 1. Don't forget your plus 1. And we can put this over 1 because 5 divided by 5 is 1, but over 1 is kind of unnecessary, so we can just rewrite it as this. Getting a little bit more advanced, let's look at the coefficients. I see 6 here, but 6 doesn't go into 15 completely. So between 6, 15, 30, and 21, 3 will go into all of them. And then if we look at the x's, we have an x squared here, and that's the lowest power, so that'll mean that we can take an x squared from everything. So if we take a 3 out of 30, we have 10, and we're going to take 2 x's, so x squared. We're going to divide 15 by 3 to get 5, and we have 1x left because we take 2 away. And if we divide 21 by 3, we have 7, and we took all of those x's away. In the denominator, we took all of the x's away, but 6 divided by 3 leaves us with 2. And so that is our final answer for that one. One more example that's a little bit more complex. We see the exponents have gotten a little larger, the numbers got a little larger, but we're still going to approach it the same way. We're going to look at our coefficients, 5, 45, 60, 15. The biggest number that would go into all 3 of those is 5. And you can even write like the GCF over here, which is what we're looking for, 5. And then we look at all the x's, x to the 7th, 2nd, 4th, and 5th. So x to the 2nd is the smallest of those exponents. So we're going to be pulling out 5x to the 2nd from all these terms. So we divide the first term by 5x to the 2nd, we're left with x to the 5th. You can write a 1 in front, but unnecessary. Divide 45 by 5, we get 9. All the x's are gone. Divide 60 by 5, we get 12. And we take away 2 x's, so we have x squared. All over, 15 divided by 5 is 3, and we have x to the 3rd left over. And that's our final solution. You will notice that we didn't divide any polynomials by more than a monomial. Doing so will require us to learn a few other things first. So to recap, we divided monomials, binomials, and trinomials all by monomials. Thanks so much for watching. See you again next time.